On this chart here, we're looking at different isotopes of various elements. You have 3 isotopes of hydrogen, 2 of helium, 2 of carbon. Remember, an isotope is of an element is where you have elements with different numbers of neutrons. And what you have here is you have the different isotopes listed, and then it shows how much it exists in the world around us. So like for oxygen 16, 99% is oxygen 16, whereas oxygen 17 is 0.037% and 18 is 0.204%. Whereas if you're looking at chlorine, 75.77% is chlorine 35, and 24% is the isotope chlorine 37. Okay, so what I'm going to try to teach you today is how they find these average masses, or weighted average masses. This is what is reported right here on the periodic table when we refer to the mass of an element. And I'm going to teach you how those are actually calculated. This weighted average mass differs from average mass in that the weighted average mass, as you'll see on the next slide, takes into account the abundance of the element. Whereas if I asked you to find like the average mass of nitrogen, the average mass of nitrogen would be 14.03, I'm getting that right there, plus 15 right here. And then because there's only 2 isotopes listed, I divide that by 2 and I get 14.5. Whereas you can see that they're reporting the weighted average mass of nitrogen to be 14.0, and that's because 99% of nitrogen is the mass of 14. Only a really small amount has 15, and so it makes more sense that you would report that the mass is 14 and not 14.5. All your science experiments wouldn't work out if you were working all your calculations assuming that the average mass of the nitrogen is 14.5. It's better to take what's called a weighted average mass that takes into account the abundance of each element. When you look at these problems, they're just talking about kind of the theory of weighted average mass. So in 21 they say boron has 2 isotopes, boron 10 and boron 11. Which is more abundant if the atomic mass or the weighted average mass is 10.81? We know that there must be, because this is closer to 11, we know that there must be more boron 11 because the weighted average mass is closer to 11. Number 22, there are 3 isotopes of silicon, silicon 28, 29, and 30, with an atomic mass of 28. Because after you take the weighted average mass, it's pulling it more towards the 28. There must be more silicon 28 because the weighted average mass is closer to 28. So to find the weighted average mass, you take the percent abundance of each isotope divided by 100, multiply it by the mass of the isotope, and you keep doing that with all the isotopes that are associated with the element. In these 2 problems it's 2, but in other problems you'll have 3 or 4 or 5. So in this problem right here, we have the percent abundance for 2 isotopes of copper, and we're asked to find the weighted average mass, or they're referring to it as the average atomic mass. The weighted average mass of copper is the percent is 0.692. You take 692 and divide it by 100. 0.692 times 62.93, and take 30.8 divided by 100 is 0.308. Multiplied by that, the mass that goes with that, when you add these up, you get 63.5. And if you look at the periodic table, that is what is listed or close to for the mass of copper, or the percent atomic mass. And the weighted average mass for bromine, they give you percentages and masses. You take the percent and divide it by 100, and multiply it by the mass associated with that. Do the same for the other one, and you get an answer of 78.91 for the weighted average mass for bromine. If we quickly here, because you have 50% of each, the weighted average mass is going to be really close to the average mass. But if you took like the average mass of these two isotopes, 62.93 plus 64.93, if I divided that by 2, then I get 63.93, which is a little higher than what is reported here for the weighted average mass, because there's more of this lower mass isotope than this one right here. So the weighted average mass ends up, the weighted average mass ends up being a little lower than the average mass. So now, using the percent abundance figures given here along with their masses associated with each element, find the weighted average mass for chlorine. We've already done copper, but chlorine, titanium, and sulfur. You and your table partners work on this, see if you can get the answer. You know you've got the right answer if you look on the periodic table, and it's what is posted on the periodic table. Be sure and keep things, this is right here, 7 significant figures. So when you're reporting your answers, keep them as 7. That will keep your results as accurate as possible.